Hi, my name is Mike Havey. I'm a Senior Specialist Solutions Architect with AWS. I specialize in Amazon Neptune, a managed graph database service. And in today's Snackables video, I'll be discussing Neptune Analytics for vectors. AWS has the most complete set of relational and purpose-built database services, one of which is Amazon Neptune. And let's begin by understanding what Amazon Neptune is. In a graph, I want to be able to explore the relationships between business objects. I want to be able to represent them in a database and then traverse those relationships through queries. So that's what graph is all about. It's not easy to build a graph database. In particular, there are random data access patterns to contend with. So you need a purpose-built service to provide that capability. And Neptune is such a service. And among its capabilities are that it is cost-effective with a pay-as-you-go pricing model. There is no hardware management and instant provisioning of compute and storage. Significant capabilities around security and compliance. A serverless database compute capability, as well as a global database feature which allows you to maintain graph data within multiple regions or geographies. And Neptune supports the three dominant query languages of OpenCipher, Gremlin, and Sparkle. Now, in a sense, it's still day one for graphs. Traditionally, customers have looked to use graph databases for online transactional processing capabilities, to represent their graph data in a form like property graph or resource description framework, RDF, and to do CRUD operations on that graph data as well as to do queries on that graph data. But increasingly, customers are looking to do online analytical processing, or OLAP, including capabilities like graph analytics, vector search, and the intent to understand broadly their linked data. Accordingly, Neptune introduced a feature called Neptune Analytics. So this is a new capability within the Neptune service. It's a single service for graph workloads where you use a single endpoint to create a graph, load data into it, and then perform analytical queries, including vector similarity search against that data. And Neptune Analytics uses OpenCipher as its query language. And because it's optimized for analytics, Neptune Analytics has very high load speeds and scan speeds. And here is a summary of the algorithms that are available within Neptune Analytics. So there are algorithms for clustering, similarity, centrality, and pathfinding. They're not our focus today, but I encourage you to go check these out. But we'll be talking about vector similarity, and in particular there are top K and vector distance searches provided. So let's discuss how Neptune Analytics supports vectors. There are two main elements of a graph. There are nodes or vertices and edges. And the idea in Neptune Analytics is that a vector or an embedding is associated with a node. It encodes the meaning, if you like, of that node. So the embedding can be anything. An embedding is really just a list of numbers. Neptune does not interpret the contents of it, but I can associate such a list of numbers with a node in the graph. I can produce that embedding through methods like text vectorization, graph neural networks, and others, and I'll demonstrate that momentarily. In Neptune Analytics, there is a limit of 64K dimension size for these vectors, and I specify that dimension at the time of graph creation. And I can load the embeddings along with the graph data itself in bulk, or I can upsert on a case-by-case basis. And the algorithms that Neptune Analytics provides to compare vectors are top K by node, which would compare the embeddings of nodes to each other. Top K by embedding allows me to compare a search term to the embeddings of nodes in the graph. And I can also calculate the distance between embeddings. It's important to understand what these vectors really represent. As I said, a vector is a list of numbers. In the figure shown on the left, I have two vectors with three terms shown, but it can be much larger in size. And if I'm comparing vectors, they have the same size, and I'm really comparing each term to each other one by one. And the distance between them is really going to be some sort of function of how close these individual terms are to each other. And we can think of those individual terms as features. So in the figure on the right, we see three features of a product. It's a shoe product, so you can see that shoe style is one feature, color is another, policy is another. And I plot this in three-dimensional space, as you see, with dots representing where each product fits in terms of its feature. And if I'm comparing two products, it would really be intuitively how close are each of its features to the features of the other product. Now, several databases support vectors. Where does vector search fit with graph? And really, vector comparison is really often part of a larger query in a graph, where the vector comparison might be followed by a graph traversal. And it's often for the purposes of explainability for similarity. For example, let's suppose that I'm an online retailer selling books, and I have a particular book called Travel Portugal. Perhaps this has been called into question. Maybe there are some doubts about its authorship. So in step one of the query, I can use neptune.vectors.topkbynode to find books with similar features that are also in my catalog. So these will be books that are similar to Travel Portugal. In step two, for those matching books, I can traverse the graph to look at associated sellers, listers, and buyers of those books. And in step three, I can return a result that returns the matching titles as well as the score, basically how close were they to Travel Portugal, as well as the associated sellers, listers, and buyers. And I can call into question maybe some of these matching books and their associated parties. All right, now let's demonstrate vectors in Neptune Analytics. So I'm here in the AWS console in my own account. In particular, I'm in the Neptune console. And we can see from the left menu that there's various types of resources I can create within Neptune. So clusters are classic Neptune databases, which are often used for online transactional processing purposes. And you can see that I've created a couple of clusters here. As for Neptune Analytics, we have graphs. I've created some here, and these are specialized for analytics use cases. And I can create one and give it a name. I can create from as an empty graph, or I can create from an existing source. And in that case, my sources can include data from an existing Neptune cluster, which would be useful if I wanted to do analytics on data that I already had in my Neptune database. I can also create a graph from a snapshot, as well as from S3 if I have some data staged in an S3 bucket. Also, we have notebooks. So these are Jupyter notebooks hosted on Amazon SageMaker. And notebooks are a power client for Neptune. I can query and run the graph algorithms from a notebook. And I will demonstrate that presently. So when I set up the notebook instance, I get several Neptune examples out of the box. So you can see in this Jupyter view here, I have several Neptune folders. Let's navigate into Neptune Analytics and then in turn into graph algorithms. And you can see that I have notebooks demonstrating several graph algorithms. Now let's focus on 06 vector similarity algorithms. So I've opened the notebook, and the data set is air routes, where we have airports and the routes that connect the airports together. And the intent is to use vector similarity to compare airports to each other. So shown here is the block of code used to prepare the embeddings. It uses a service called Amazon Bedrock, which provides API access to several language models. And in this case, we use Amazon Titan Large Language Model to prepare the embeddings based on airport records. And once we have those embeddings, we can use Neptune.load to load the graph data as well as the embeddings into the Neptune graph. So in the Neptune graph, we can also look at these embeddings through neptune.algo.vectors.get. So let's get the embeddings for the Seattle and Anchorage airports. And we can see in the results the embeddings for Seattle and for Anchorage. We can also determine vector distance. So by using neptune.algo.vectors.distance, we can get the distance from Anchorage to two other airports, to Seattle and Fairbanks. And you'll notice that the distance between Anchorage and Seattle is somewhat high at 116, whereas Anchorage Fairbanks is 80, a bit less, indicating that these airports are more similar to each other. We can also compare the embeddings of nodes to each other for similarity using neptune.algo.vectors.topk by node. So if we look at the airports whose embeddings are closest to that of Anchorage, we can see in the results that the closest airports all appear to be northerly airports, many in Alaska itself. Distance doesn't necessarily mean geographical distance, however. Let's run the similar query, but for Manchester Airport. And we'll see that among the results, the second highest match is actually Manchester Airport MHT, which is in New Hampshire, USA. Our source airport, Man, is in the UK. The distance is not close at all geographically, but the airports have similarities. Indeed, the names are identical. All right, to wrap up, let's review the key takeaways. Neptune Analytics addresses the needs of online analytical processing and allowing you to do graph analytics and vector search. And vectors and graph is really all about explainability for similarity. Neptune Analytics stores and queries vector embeddings, and those embeddings are associated with a vertex in a graph. And Neptune Analytics provides topk and distance algorithms. And you can bring your own embeddings. We saw by example using a large language model to create embeddings. You can also use a BERT model, that's bidirectional encoder representation. It can vectorize text. And a graph neural network can vectorize nodes and the neighborhood of a node, and it's a way of providing a graph-aware embedding. And so some additional resources, videos from reInvent 2023, at which Neptune Analytics was announced, documentation on Neptune Analytics, the Neptune Demos Hub, and if you'd like to try to deploy Neptune in your own account, some instructions here on how to deploy a Neptune database cluster and how to create a Neptune Analytics graph. And if you'd like to discuss further, my team's email is wwso-neptune-ssa@amazon.com. We'd love to discuss with you. My name is Mike Havey. Appreciate your time today. Good day.